Hi, Simon here for Joranalogue Audio Design. We're nearing the end of the year, and I know a lot of YouTube channels that work in the Eurorack realm and in the gear space in general kind of do best of the year overview video. I don't want to do that exactly, but I want to walk you through all the modules that I have in my rack, which is the complete catalog of Joranalogue Audio Design. And I want to tell you a little bit about each and every one of them, kind of my personal backstory with them or the things that I like most about them. I'll show you a few tricks that I picked up over the years. So there's going to be some sounds in this video apart from me yapping away. So I hope that you are somewhat interested in hearing me talk about these modules, because that's what you're going to be hearing if you keep watching this video. By the way, I'm filming this view here on an old crappy webcam. So if you are wondering why this view here looks a little bit like it is filmed on a potato dug up from the Second World War, that's why. The first module here in this row is step 8, as you can see. I love step 8. What's not to love? You can use step 8 as a sequencer, of course, and if you set these knobs to a value, that's the pitch that you are going to get. Let me quickly demonstrate this by sending the scan output into a volt per octave input on cycle 5. Let's monitor the triangle wave, and then let's send a clock into step input on step 8. So this is one of the interesting ways that you can just use step 8. Well, I personally don't do this a lot. What I prefer to do is use the sampling feature of step 8, because it's also an 8-stage sample and hold, which is kind of awesome. And let me show you how I implement that. So what I like to do is send in a chaotic CV signal, but you can just use an LFO or even some noise. So you send some kind of random signal into the signal input of step 8. Preferably I offset this signal a little bit, but let's just keep it as it is. And then if you turn certain steps down on step 8, those will always give you the root note of your melody, but the ones that you keep up or open will give you an attenuated version of the sampled voltage at that stage. Which results in melodies that are a little bit random, but you have some control over them. Now, let me quickly run this signal through an external quantizer. And you can choose which steps are bass notes and which aren't. You can, for example, decide that you want this 7th step here to be a little bit more extreme. And all of it depends on the voltage that's going in, of course. It's just sampling the voltage and attenuating it according to the setting of the slider. I really like using step 8 for something like this. There's no other module that gives you this functionality. To the right of step 8, we have two Generate 3 modules. Generate 3 is the module that started my whole Joranalogue journey. The first in-depth demo tutorial, if you will, that I made on YouTube was about Generate 3. I made a 3-part series. I think I even made a few add-ons about Generate 3 because it's, well, just an oscillator that can do everything. Now you can use this full output here. And this is a unique thing on Generate 3. You have control over the separate harmonic generators. So there's a sine on the fundamental channel here, or the fundamental knob. There's a saw wave that's 1 octave, it's pitched 1 octave higher, and then there's this weird odd wave that if you combine it with the other waves, you can make a square out of. You can invert those, so you can really have endless sounds with this module. One of the things that I like to do when using the full output is just using a few random or chaotic voltages to control the levels of these harmonic generators, which gives us a sound that's always changing in timbre. And you can exchange this voltage for maybe something from an envelope generator, and that's just instantly interesting, at least to me. Let me do this here quickly. And I literally could go on about Generate 3 for hours, and I have, but I won't in this video. But one other thing that I really like to do with Generate 3 is just take the sine or fundamental output and start using the phase modulation. And it doesn't really matter which source you use for this modulation, as long as it is audio rate. Let's take an output of cycle 5 here, and I'm just using the sine wave here as well. And let's patch this to the phase input on Generate 3. If I then turn up the phase modulation, you can hear how awesome this sounds. And I like this a lot more than just using FM, honestly. To me it sounds, well, it's just a personal preference. It sounds, to me, more interesting, more pleasing than FM. But while Generate 3 gives you all the options, it has exponential FM. You can do ring modulation. So here's the regular FM. But there's also through zero FM. which can be a little bit hard to control, well, unless you have done it hundreds of times and you know where the interesting settings are, because, well, they are there. To the right of Generate 3, we have Fold 6. Fold 6, I think I got it together with Filter 8. I got them at the same time. Fold 6 is just an interesting wave folder. It's a combination of several different topologies, I think, but that's all very technical. Let's just listen to it and I'll show you what I like to do with this. So let's send in a sine wave made with Filter 8. So you can do all kinds of interesting things with this module sound-wise. But the thing that I like to do most on modules like wave folders is modulate them at audio rates. Let's modulate the fold parameter, which is just the amount of wave folding. Now this is a sound that I enjoy very much. Yeah, this is what I like about wave folders and wave shapers, that you can do this kind of things, these kind of tricks with them. And if you start filtering a sound like this, let's use, I think this is off screen. Well, no, it's barely on screen, but it doesn't really matter. Let's use Collide 4 here to filter this a little bit. I think that's really interesting. Let's try modulating this filter really quickly with step 8. Yeah, I think that's really interesting. Maybe I can do some feedback patching here using the alternative output and select 2 to invert this signal, because why not? Let's send this into the shape input. This isn't doing a lot. Let's send this into Collide 4 instead. I really like this, but let's move on. Now we have Filter 8 here. I know a lot of people start their Joranalogue journey by purchasing Filter 8, and I can totally understand why, because it's such an overpowered filter, if you ask me. And I really have to invest in a second one to use this for stereo operation. But let's send some sound through it. A good wave to send through a filter is always a saw wave, in my opinion. I'm partial to the sound of a saw wave through a filter more so than a pulse wave. So the resonance is halfway. Now it's turned down. Filter 8 has a second audio input. Let's send some noise through it coming from walk 4. Yes, there we have some. Of course, there's the several outputs that give you different flavors of filtering with different poles, like the 4-pole low pass, which just has a little bit of a steeper fall off at the top. I also like the band pass output. And what can be really interesting is patching up feedback, for example, into the FM input here. Let's remove the noise so you can hear more what this feedback is doing. I mean, this sounds really cool, especially at this breakup point here. Let's use another output here. Yeah, it's really cool. But one of the things I use Filter 8 for the most is actually not for filtering, but for its self-oscillation to create sine waves with it, both at audio rates and LFO rates. An interesting sound happens when you start modulating Filter 8. You can use the linear FM here, which sounds totally different from the exponential FM, as you can hear. And then if you start pinging this filter, which is easy because it has its own ping input, you just need to send in some kind of, well, signal. It doesn't really matter that much what it is. And as you can hear, it sounds really nice. I think this sounds really interesting. And then you can, of course, start patching more things, like maybe this here. Let's move on, shall we? Let's go down here to Receive 2. I haven't been using Receive 2 as much as I thought I would, simply because I personally don't use a lot of external sounds, but I do have this field recorder and it's just a breeze to hook it up to Receive 2 and, well, get it up to modular levels. I don't have it lying around here, and I don't think the jack output on my phone is working, so I'm not going to demonstrate Receive 2, but well, it's just really good at converting anything you throw at it be it a microphone or, like I said, a telephone if you have one with a working jack output, or a field recorder. Next to receive 2 we have route 4, which still is, if I'm honest, still is kind of an enigma to me a little bit. I think when route 4 came out, I was on holidays, or maybe I think I was moving, like moving house really. So I didn't spend a lot of time with that module initially. But one of the things that I do like to use route 4 for is to transpose melodies. And well, that's just one of the hundreds of things that you can do with it. But well, it's the one thing that I use a lot. Let me first get a sequence running here on step 8. Let's use the variwave output on cycle 5. Let's modulate this. No, let's modulate the timbre of cycle 5 with an attenuated output of orbit 3. That's nice. Let's increase my clock speed here. And then if I connect the output of step 8 to the full positive input on cycle 5, we have this unquantized melody, which is kind of alright. Something like that is okay. What you then can instead do is run your sequence through route 4. Run its output into your VCO. And if you then set up these switches in the right way, you can use the other channels that don't have something connected to the inputs. You can use those to transpose your melody by an octave. You can send like voltages coming from orbit into it, but you can also use gates, for example. You can really do what you want. What else can I send in here? Let's choose like a random walk from walk 4 to send in here as well. So that's the thing I use route 4 the most for, but well, you can do so much more with that module. Next to route 4 is switch 4, which is an awesome switcher. It switches silent, so there's no pops or clicks between, when you switch between signals or between on and off, which is really important if you use it for audio. But you can also use it to route triggers and stuff. Let me try and demonstrate this. First I'll make something like a bass drum on Collide 4. really a bass drum, but I like this sound, so let's just use that. And let's make some kind of hi-hat, I don't know. Maybe this is okay. So we have this steady pattern for our bass drum as well as our noisy hats. But suppose I want to be able to control the pattern for my bass drum or bass synth. I can send it through switch 4. And go from there into the ping input. And then with these switches, we can turn this pattern on and off. You can also do it momentarily. And if I make a different pattern, I can also send it into switch 4. So if I now go to the B section here, and we can use switch 4 for both triggers and audio at the same time. So let's just do that. So now I've routed my noisy hi-hat through switch 4 as well, so I can mute it. I can unmute it also in this momentary way, or just turn it on. But I think it's interesting that you can do stuff like this. There's endless possibilities here, but it's a really, really powerful switcher, and I should use it a lot more in performances. I have used it to great success, especially for changing up drum patterns, but I guess I'm too lazy to patch it up, but maybe that's a good idea for 2026, to be less lazy in my patches. So next to switch 4 is compare to. I really, really, really like compare, and if you have a compare to and you don't know what to do with it, be sure to check out the guide that I wrote for it. It's a really practical document that runs you through a couple of patches that you can do with this module and a few other utilities. It is on the web page for compare to on the website joranalogue.com. If you haven't read that and you don't know what to do with compare to, well, maybe you can get your mind blown, because there's so much more that you can do with it than creating drum patterns with it, because that's what I notice a lot of people do with it. So for example, running a sine wave into one of the channels here and then extracting some kind of trigger from it. Let's ping filter 8 with this signal coming from compare to. And then if you start sending in more related or unrelated LFOs into the second signal input here, you can extract different triggers from, for example, the logic section here. Let's ping collide 4 as well. So this is going to be going into the right signal here. So a lot of people do this kind of thing with compared to, which is totally okay, but there's so much more that you can do with it. And actually preparing to write that guide was an exercise, because I myself didn't know what to do with compared to as well, or comparators in general. I mean, I understood how they operated, but what I could do with that function, that mathematical function, was a little bit of a mystery to me. So I started looking around the internet in what circuits comparators were used, and well, my mind was blown to find out that you can do so much more with them. One of the things you can do with those are creating super sauce from regular sauce, which is not something I first thought of when I got this module. Let's continue our journey across these modules with Select 2 here. I really like Select 2 a lot. I use it all the time for simple attenuation or inversion tasks, and offsetting as well. Because when you use the last output here, together with the first input, you can attenuate a signal with the first channel of Select 2, and then you can offset it with the second one. And you see this in a lot of attenuation and mixer modules, but I always find it so useful when the signals are chained like that. I use this a lot when I patch up orbit 3, for example, into step 8 to create a melody sampled from the voltages from orbit 3. But like I showed earlier in the video, let's patch it up really quickly. And as you can hear, the range of the voltages is pretty large. Now you can attenuate these voltages on step 8 itself. But well, imagine that you're using something else than step 8 to sample these voltages without built-in attenuation. Well, then you have a problem. So what I then do is connect the second output of Select 2 into the sampling input of step 8 and connect the output of orbit 3 to the first signal input here on Select 2. And this gives me the option to not only attenuate my voltages coming from orbit 3, but also offset them. Which can be, like I said, a very useful feature in a lot of circumstances, really. There's a lot more that you can do with Select 2, because you have the select input here that switches between the two inputs, because it has two signal inputs per channel. There's also the hold input that holds a voltage. Then of course there is orbit 3, probably my all-time favorite Joranalogue module. It was the first module that I got the prototype of. Me and this orbit 3 took our first steps together into being a tester for the Joranalogue team. I have big feelings for orbit 3. Orbit 3 is a chaos oscillator. It gives you not random, but chaos, CV or audio rate. And I just love it. Now, to demonstrate really quickly what I really love to do with orbit 3, let's connect two outputs of Generate 3 here to my output module. So one Generate 3 is going into our left ear. The other one is going into our right ear. And then if I connect these out of phase outputs to the inputs of the harmonic generators here, you get this interesting movement left to right that's really unique to these out-of-phase outputs on orbit 3, you can hear that, well, I can connect the inverted outputs here. These are 180 degrees out of phase. And then it's just left to right, which is kind of imbalance. But when you start connecting outputs that are not exactly 180 degrees out of phase, you get this, to me, more interesting motion from left to right. Be sure to listen on headphones or a good speaker set to be able to get this effect. But there's plenty more that you can do with a module like Orbit 3. You can create audio signals as well, which you can control with a sequencer. But if you want to know more about Orbit 3, I made a multi-part video series on my own channel called Bris, where I go into all the details of Orbit 3. That's literally hours of content about this module alone. But I really love it, and for me it has a special place in my heart, because like I said, this was my start of working together with Joranalogue Audio Design. Let's move on. Next to Orbit 3 we have Add 2. Add 2 is a 2-channel precision adder, so you can add precise sequenced voltages, or non-sequenced voltages as well. You can also change a jumper on the back to have it average the signals that you send in. There's literally thousands of things that you can do with this kind of utility module. Add 2 is a really useful module to have in the rack. Let's move to the right of that. There we see Pivot 2. Pivot 2 can be a really confusing module because you can do a lot of things with it that you wouldn't think of straight out of the box, but it takes some understanding of the signal routing in this module to get the most out of it. So I suggest, if you have a Pivot, to really study the manual, take a look at a few videos about this module, because, well, there's more to it than meets the eye. But one of the main things that you, of course, can do with this module is route an audio, or CV, but let's talk about audio. Route an audio signal through two processors, like a filter, a wave folder, distortion, wave shaper, you name it. And with one twist of a knob, you can route or chain these processors in different orders. So imagine you have a VCO going through a filter and then a wave folder. With Pivot 2, if you connect everything to these jacks here, you can switch the order. So the signal is going first into the wave folder and then into the filter by just turning a knob here. Let me quickly try and demonstrate. And then by just turning the pivot knob, you can switch out the order of these effects. Which of course can be really interesting if you start patching like feedback between these modules. And of course you can also modulate all of this with CV. But like I said, there's plenty of other things that you can do with Pivot 2, but it takes a lot of understanding. It looks like an easy, simple module, but there's a lot of clever circuitry behind this front panel. Let's move on. To the right of Pivot 2, we see Link 2. Link 2 is a buffered multiple, which you can use if you want several precise copies of one signal. For example, if I want, let me quickly patch up something here first. So maybe you want to use the core output of this Generate 3 here to modulate your filter, but you also want to modulate the frequency of your VCO. Then you would need to use one of those stackable cables if it's not that important for the signal to be precise. But instead you better can use a buffered multiple like Link 2 that lets you, well, like I said, make several copies of one signal. Like that. There's two channels, so there's two inputs with each 3 outputs. You can also just use one input and have 6 copies of the same signal. Now let's have a look at Mix 3. Mix 3 is a pretty utilitarian module. It's a 3-channel VCA with actually a 4th input here as well. You can use that input if you, for example, chain several of these Mix 3 modules together. There's separate CV inputs for the VCA for the 3 channels, and there's also a global input that lets you attenuate the mix of all 3. Let me quickly try and patch something up here. Maybe something like that. Then imagine you want to attenuate all 3 of these together. Then you can, for example, use an output of contour 1 into the global level input here. Now, as you can hear, if you send in higher voltages, you can start distorting this module, and it's designed to do so. So if you don't want the signals to distort, you need to turn down these attenuators here. Or you can attenuate your CV, of course. But of course there's plenty of possible uses for a clever and good VCA module like Mix 3. Let's jump back up a row. We stopped at filter 8. Next to filter 8 we have bias 2. Bias 2 is a module that has 2 channels. One channel gives you the option to divide a signal by 2, offset it by 5 volts. Actually, it's offsetting first and then dividing. The other channel lets you subtract 5 volts and multiply your signal times 2. But you can also just use it to offset your signal with 5 or minus 5 volts. You can also use it as a precision mixer for 2 times 2 signals. And you might wonder, why the hell do I ever need a module like that? Well, for example, imagine that you want to use contour 1 as a VCO. Well, this signal lives between 0 and 10 volts, which is unlike most VCOs in Joranalogue. With bias 2, you can adjust this signal. So if you send it into the second channel input, what first happens is there's 5 volt subtracted from this 0 to 10 volt signal, which means it at that point lives between, let me show you, because you have an output here for that. By subtracting 5 volts, your signal now lives between minus 5 volts and plus 5 volts. And then if you use the times 2 output, you can now see on data that the signal is indeed between plus 10 and minus 10 volts. And you can also do it the other way around. Imagine you have a bipolar signal living between plus 10 and minus 10 volts. And then if you use the first channel of bias 2, you can change that signal into living between 0 and 10 volts and being strictly unipolar. One of the things I use bias 2 for a lot is, well, exactly the same thing that I showed you with select 2, namely for offsetting and attenuating a signal, for example, coming from orbit 3, before I send it into a sample and hold module. So instead of a signal with a wide voltage range between 10 and minus 10 volts, you can send a signal to your sample and hold module that's a little bit attenuated and also offset into the positive part of the voltage range, just so your sample and hold module doesn't sample negative voltages. But of course it depends on what you want and what you need. To the right of bias 2 we have contour 1. Contour 1 is an envelope or function generator with a lot of bells and whistles, but I simply use it most of the time as an envelope generator for controlling the cutoff frequency of a filter. So I quickly patched up something here, 2 signals going into the filter. And then if I want to control this filter, you can just use contour 1 to do so, which is a really classic subtractive synth patch, of course. You can also use contour 1 for slewing voltages. For example, if you have a stepped random coming from a sample and hold, like step 8 for example, you can slew it a little bit so the changes are less abrupt. Stuff like that. Contour 1 goes well into audio rates. And it also has CV inputs that control about every aspect of your slopes. And there's more tricks to this module, like you have a hold input that holds your voltage whenever you send in a high gate, etc. Next to contour 1 we have cycle 5. Cycle 5 is like the latest VCO addition to the range. One of the really interesting things about cycle 5 is that you can use it as a reference for tuning of your VCOs around your system. Let's take, well, I'm a fan of the saw wave, so let's just stick to that. So imagine I want to start creating a patch and I haven't tuned my oscillators. Then I can just use cycle 5 as a reference to tune my other oscillators too. Like that. And then you can be sure that your VCOs are all tuned to a middle, well, not a middle C, but a C somewhere along the octave range. Another very interesting feature about Cycle 5, of course, is the vary wave output, which, by the way, also operates at low or LFO levels. What the vary wave output gives you is a varying wave that goes from sine through triangle into a saw wave that morphs into a pulse that becomes a narrow pulse. You also have a PWM output here. And you can of course modulate this with CV. And if you send two of those signals into a nice filter, you can get really beautiful warm sounds. Let's move back down here to Enhance 2. Enhance 2 is a really interesting stereo processor that lets you pan or balance signals between left and right. There's also interesting mid-side tilt EQs to control the overall frequency range or frequency response of your mid and side channels. But what's most interesting to me about Enhance 2 is that it lets you process the mid and side channels separately. And if you don't know what mid-side is, it's just a different way of looking at a stereo signal. Instead of looking at the left and the right as separate signals, it does some interesting computations to see what is the same between the left and the right signals and what is different between the left and the right signals. And it takes that portion that is the same as the mid signal, and it's a separate circuit for that, and then it takes everything that is different as the side channel, and there's also a separate circuit for that you can separately sent through processors. Let me quickly patch something up because it's actually something that's really cool. So let me send two outputs of two separate Generate 3s here into the left and the right inputs of Enhance 2. And if I then take the left and the right outputs of Enhance 2, you will hear that the signal is just running through the module unchanged. Let me tune these VCOs. Now let me make sure that these harmonic generators are set up a little bit different on both modules. So we actually have some stereo going on. Let's additionally connect an output or two of orbit 3 to create even more difference between the left and the right signals. Immediately on Enhance 2 you can see the phase correlation between the left and the right signals. Long story short, your stereo signal will behave okay in a mono environment as long as this is between 0 and +1. So everything in the red is kind of bad, but well, there's a little bit of a gray zone in the middle there. Now, as you can hear, this is a nice stereo signal. Now imagine I take the difference between these signals and route only that through a wave folder. And you'll hear how cool this sounds. In 3, 2, 1. You can hear that the stereo spread is even bigger now. You can also take only the mid channel, run that through the processor, which sounds completely different. You can also run this, let's do that as an experiment, through well, a saturator maybe. Which creates saturation now only for the center portion of the stereo spread, and there's no saturation on the outer edges of your left-right hearing range. But let's change that out to having saturation only on the side channel. You can see how our phase correlation is -1. So this might not behave very nicely when you collapse this to a mono signal. But you can also just use Enhance 2 to like auto pan a signal. And there's more tricks that you can do with it. To the right of Enhance 2 we have Collide 4, the collaboration module between Joranalogue Audio Design and Heinbach. Collide 4 is the modular take on a lock-in amplifier, which is usually a giant piece of test equipment used in laboratories to measure very precise voltages. But Collide 4 is really just a noise machine, which you can also use for really precise voltages if you want. What I like to do with it is, well, a giant underuse of this module, but I just like to ping its filter. So I'm just creating some sampled voltages here on step 8, which I will quantize using an external quantizer, just so I can sequence these nice pings. Well, apparently I'm doing something wrong here. Let's try this. And while you can distort and saturate this signal to your heart's contempt, Collide has plenty of gain on tap. But honestly, I just like how this sounds when it's clean. Of course, as soon as you start using other outputs here, you can start hearing the madness that is Collide 4. Let's try this output. There's plenty of sounds to be found in this giant module. This really is a bonkers module. Yeah, very cool. Let's move on, shall we? Let's go back up here to Walk 4. Walk 4 together with Warp 1 are the latest additions to my rack. These are still prototypes. We're beta testing these units, but in a matter of weeks you will be able to purchase these modules. So yeah, Walk 4. Walk 4 is a quad Brownian accumulator. It says so on the front panel. An accumulator adds voltages, and Walk 4 does this very precisely. You can send in, for example, 1 volt, and then if you let it run, it has its own built-in clock. With every clock pulse it will add precisely 1 volt. You will be able to use this for sequencing implementations. You want to make sure that it's precise enough that you can use it for offsetting or transposing melodies. I haven't spent that much time with the module yet, so I can't tell you what my favorite use of it is. But one of the things that got me excited about this module has actually more to do with the noise generators that are built in each of the 4 channels here, which you can use to kind of sample and create stepped melodies. But keep in mind, these voltages, these random voltages extracted from noise, will not just be sampled and held. No, they will be accumulated. They will be added to the previous voltage, which means that the kind of random that you get out of a module like Walk 4 is not entirely the same thing as another generic stepped random. In fact, let me try and show this to you. Now let's just send the full output. I'm not constraining it into an attenuator here, and let's use it to sequence cycle 5. And well, while we're at it, let's just quantize this voltage with an external quantizer. And the beautiful thing is that you have 4 of these generators, these accumulators, so you can patch up your own clock to each and every one of them. Which means you can do quad random or Brownian melodies. Or you can use the other ones at audio rate. It's really a matter of what you want. As you can see, when I turn down the volatility which attenuates the noise in the circuit, you can just set a voltage here with the trend, and the module will just start adding these voltages together. And you can combine these features. You can use a second Brownian stepped voltage to control other parameters. Let's sync cycle 5, because why not? If you want the full rundown of this module, be sure to check out the video on our channel. It goes into the features of the module a lot deeper than I can do in this overview video. Then to the right, if we jump across data here, we have the wonderful MORPH 4. MORPH 4 is really a boss of a utility module. It's a 4-channel VCA, but it's much more than that. You can use it as a 4-channel scanner. And then if you use the MORPH parameter here, you can scan across these 4 channels, which can give you really nice like faux wavetable behavior. But there's plenty of things or tricks that you can do with this. You can use it as a stereo VCA. You have min, max outputs. There's an averager, there's an adder. Like I said, you can just use it as a 4-channel VCA as well. I've used it a lot as a mixer, and then I used the built-in VCAs to add like sidechain attenuation. But I also really like to use it to scan and mix 4 different wave shapes together. Let me quickly patch something up here. So here we have a nice stereo situation. I have 2 wave folded signals, VCOs, going into A and C, which is left and right. Then I have 2 outputs of cycle 5. One is the PWM output. The other one is the VariWave output, modulated with the same CV source. So these are also left and right and combined. It sounds like this. And what you then can do with a module like MORPH 4 is start moving between them. Let's just turn a few knobs here for the position. Maybe I should do it like this. Can decrease the amount of space all the VCOs take up, so the transitions are a little bit less gentle. You can do a lot of creative things with this module. I like to keep the span somewhat almost completely open. Then the transition between these sounds is really gentle, and of course you can modulate all of this with CV. Let's send in a slow moving voltage from filter 8. You can also use this in mono operation. Then you can switch between or morph between the 4 voices. what's really awesome with this kind of morphing faux wavetable sounds is running it through saturation or some kind of wave shaper. Let me try and demonstrate this with Collide 4. Let me keep this patch running while I jump to the right here. This rule 1 is just 3 HP blank with a few interesting measuring features on it. But to the right is a real module here, which is transmit to. As you can see, I use it to run my synth into my into the next stage of my recording setup, which in my case is my sound card. There's an interesting main level control here. You can immediately see the level of your output from the LEDs. You can see if you're clipping or not, which is really a useful feature. You have a stereo headphone output with its separate volume control, which can be really useful in a lot of environments really. Let's disconnect Collide 4 from the patch that we're running in the background here, and before I talk about Warp 1 here, which is the next one in line, I want to send this morphing synth through this wave shaper here, because it's actually one of my favorite things that I've discovered with Warp 1, and that is sending these kind of morphing sounds through it. It does a really great job at distorting and shaping these complex sounds into something really wonderful. And of course there is voltage control over every aspect of this module. Let's remove all of this. So yeah, Warp 1. Warp 1 is another prototype in my case that I'm testing out as a beta tester for Joranalogue. So far I haven't discovered any issues with this prototype. It's really interesting module. Joran told me during development that he was thinking about calling this a utility wave shaper, and that would be a fitting description as well, because it has quite a few clever utility features on board. So this is a nice sine wave coming from cycle 5. And not only gives Warp 4 us the option to shape our waves, you can also use it to clip at really precise voltages, as you can see on the scope here. You can do complete asymmetrical clipping while still shaping just a sine wave running through, and you get all these weird shapes. There's a completely different setting that behaves completely different, called hyper. You can also use the module for full wave rectification, which is interesting. Long story short, you can do a whole lot with Warp 1. And I'm really excited to find out what people will do with this module in their racks. Let's jump to the right here. There we have Delay 1. Delay 1 is a Bucket Brigade delay module. These types of delays are useful for really short delay times that you can use to create phaser, chorus type effects, or core plus strong synthesis. What sets Delay 1 apart to regular BBD delays is that it has really high pitched clock that's outside the audible range, so you don't get the high whine that's usually associated with BBDs running at their lowest speeds. And this means that Delay 1 can operate squeaky clean, which is very atypical for a Bucket Brigade delay. Let's quickly create some chorus with the module by sending a saw wave into it. Maybe I should filter that saw wave first. Let's send one of the outputs into transmit 2 here. Now when I start turning the coarse tuning here, you can hear that you get this typical pitch movement that's related to changing the delay time on an analog delay. And it's this effect actually that's being used if you use it to create chorus type effects. Or maybe I should take a sine wave. I think this would sound better with a chord, so let's quickly patch one up. Something like that, and then if we reintroduce the time modulation, if we increase the speed, we should decrease the intensity. Maybe I can modulate my filter frequency here with an output of orbit 3. You can also really crank the feedback on Delay 1. Let's slow down the modulation and increase the intensity, and you get really wonky stuff like this. Cool comb filtering effects like that. And while this is not the best patch to demonstrate the behavior, you can also send in your own slower clock which gives us all the grungy lo-fi goodness that is usually associated with regular BBD delays. Let's remove all this. We have one more module to feature here. Don't mind this Synthesystem VCF, but to the right of the Synthesystem VCF we have DIM2. And let me bring the lights of DIM2 into frame to show you what it can do. DIM2 has two lights with nice potentiometers, so you can attenuate the brightness of these lights separately, and of course you can use voltage to control the brightness of these lights as well. So you can send in, for example, gates, or like I first did, just slow moving voltages. Let me turn this away from the camera so it's a little bit less obtrusive. So you can use DIM2 for crazy light shows when you're performing, but you can of course also just use DIM2 to light your rack. Now of course I use studio lights to light up my rack. So I haven't been using DIM2 a lot. I don't want to cause epileptic seizures for everyone watching every time I make a video. But it is a cool effect if you start connecting events from your patch to a light source. That's really interesting. But that's it for this rundown of the modules of Joranalogue Audio Design Anno 2025. I hope you enjoyed this video just a little bit. If you're still watching, you probably did, which is totally awesome. And well, you're probably going to see a bit more of me in the future, since I plan to make more videos for the Joranalogue Audio Design YouTube channel, but Instagram, TikTok, Facebook and X as well. I hope you enjoyed this video. I wish you a very nice end of the year. This was Simon for Joranalogue Audio Design. See you next time. Bye.